Okay, our next question says, if sine x is equal to 2 over 7, we should, excuse me, we should simplify, or we are to determine the value of tan x take away cos x. This is what we are to find. All right. Now, this particular problem is taken from the properties of right angled triangle. So for a right angled triangle, if we have right angled triangle this way, right? Ensure that we draw it so that it looks good. Okay? If it is right angled at this point, okay, to be able to get the sine of the angle, assuming the angle is located here, you can place the angle on any part of the diagram. All right, the angle is here. To get sine x, we will have to have opposite over the hypotenuse. So this side is the opposite to this angle, so that is 2. And then the longest side of the right angled triangle is the hypotenuse. So that's that. The relationship between this angle, this opposite side, and then this longest side will produce this. So using properties of right angled triangle, our sine x from the diagram is equal to opposite over the hypotenuse. In the same way, also our cos x is adjacent over the hypotenuse. And then our tan x, okay, is going to give us opposite over adjacent. Now, this relatively provides sufficient information about how the three sides of the right angle triangle are interacting. So we don't know the adjacent. This side is called the adjacent to this angle, so we may call it as side y. So to be able to get side using Pythagoras theorem, all right, the square of the longest side, our 7 squared, is equal to the sum of the other two sides. So this is what we can write out from Pythagoras theorem. So if we do this, it means we have 49 take away 4, that will make our y squared. Therefore, y is equal to 45. Okay? When we find square root of this 45, the result will give us y. Right? Which is the same thing as, can write it as 3 root 5. Since 45 is 9 times 5, square root of 45 can be written in short form as 3 root 5. So we got this side now as 3 times square root of 5. So we can write out all of this now from the diagram. So we come here, we're going to have, already we know that, so cos x, which is opposite over the hypotenuse, cos x, which is adjacent over the hypotenuse, is going to be 3 root 5 divided by 7. That's this adjacent divided by this longest side, that hypotenuse. And then tan x equals opposite over adjacent. That's going to be 2 divided by 3 square root of 5. Right? 3 times square root of 5. So we got this expression now. So if they want us to evaluate tan x minus cos x. By substitution, we will have 2 divided by 3 square root of 5, or minus 3 square root of 5 divided by 7. So simplifying, we find the LCM for the two terms. That's going to be 3 square root of 5 multiplied by 7 multiplied by 7. So 3 square root of 5 cancels 3 square root of 5. You're left with 7. 7 times 2, that's going to give you 14. And then 7 will cancel 7, you're left square root 3 square root of 5 times 3 square root of 5. So what that means is that we have 3 square root of 5 all squared. So if you do that, you're going to have 14 minus 9 times 5 divided by 3, all right, divided by 3 square root of 5, right, all times 7. So if we do it, we have 14 minus 45 divided by 3 square root of 5 times 7, which is the same thing as minus 31 divided by 3 square root of 5 times 7. Now, if that we should go ahead and rationalize. So if we decide to, this expression means that we have minus 31 over 21 square root of 5, because these 3 outside multiplied by 7 will be 21. So if we rationalize, that is going to give us minus 31 times 21 square root of 5 divided by 21 square root of 5 times 21 square root of 5. So what we have here is this 21 we cancel this 21, all right, and then we have square root of 5 times square root of 5. That's going to be 5. So the result finally is going to be minus 31 square root of 5 divided by, so 21 times 5, that's going to give us 105. And this is the result in solved form, remember. So this is in solved form.